Modular division. Modular division is when you divide using the percent sign. What it does is it calculates the remainder when you divide one number by another. So the way we're going to think about this, we're going to talk about the number of jelly beans and the number of people. So imagine we have 10 jelly beans and we have 2 people. Is there a way to split the jelly beans evenly between the people? And the answer is yes. Everyone would get 5 jelly beans. When you do that, the 2 people get 5 jelly beans each. Nothing is left over, so the remainder is 0. What if there were 9 jelly beans? With 2 people, each one would get 4. That leaves 1 left over. What if there were 10 jelly beans and 4 people? With 10 jelly beans and 4 people, everyone would get 2 jelly beans each, and 2 would be left over. So that's our remainder. Let's do some more just for fun. 11 jelly beans and 4 people. Everyone would get 2 again, and we'd be left with 3. 12 jelly beans and 4 people. Everyone would get 3. Nothing would be left behind. So it just calculates a remainder. And what you might be asking yourself is, who cares? You do. One thing it's useful for is to check if one number divides evenly into another. Great for testing things for even and odd. Useful in things like animation. If you're animating between different forms of a person moving, and you want to draw one of the forms on an odd count and a different one on an even count, we could draw this one when it's even and this one when it's odd, and we'd alternate between the 2 images. So it's really quite useful. What would your code look like? Calculate the remainder when you divide by 2. If the remainder is 0, example, 4 jelly beans, 2 people, nothing left over, then it means it goes in evenly, and that tells you you have an even number. Every other situation is it's odd. So either you're even or odd, and this just tells you if there's nothing left over, then that's an even number. And again, what we're saying, imagine there's 2 people, even number of jelly beans, no remainder, and that tells you whether a number is even or odd. What else can we do with this? It's used for separating digits. Imagine we have the number 2, 4, 3, and we want to split it into the separate digits 2, 4, 3. Here's some interesting code. All right, we're going to start with a number. Let's take a specific example. Let's take the number 2, 4, 3. Digit is going to equal that number when you divide by 10. So when you divide by 10, it would go in evenly 24 times and leave the digit 3. We then print the digit 3, so 3 appears on the screen. Then what do? Divide the number by 10. When you divide 2, 4, 3 by 10, you get 24.3, except in Java, if number has been declared as an int, it will automatically get rid of the decimal for you. So because this is Java, integers are integers. And when you divide by 10 and there's a decimal, the computer goes, well, you obviously weren't interested. So it's now the number 24. When you divide that by 10, it goes in 2 times with a remainder of 4. 4 now appears on the screen. Divide your number by 10, you'd get 2.4, except this is Java, so it automatically rounds it off. Calculate your remainder. It's 2. Put your remainder on the screen. Divide by 10, you'd get 0.2. Computer will round that off, and 0.2 just becomes 0. What happens when we become 0? We exit the loop. So what it ended up doing was ripping the digits 3, 4, and 2 off from the number. So let's check. The 7 comes off first, then the 6, then the 5, then the 3, then the 1. Really useful if you want to check individual digits in a number. So remember this piece of code. Another useful example, it's to tell if a number is prime. So I'll just walk you through the code and we'll see what it does. We're going to start I at 2. Okay, so I is equal to 2. We have a number. We don't know what that is yet, so let's just take a number and see what happens with this code. Let's just input 5 and see what happens. We start at 2 as long as we are less than half the number. So we're only going to go from 2 to 2.5, not very far. If the number 5, when you divide by 2, equals 0, so if it goes in evenly, we have a variable called is prime that we're going to set to false. All right, so at the moment, is prime is true. So is prime starts at true. And we'll see what happens. So we start with is prime being true. So let's check. When you take 5, dividing by 2, 2 people, 5 jelly beans, I think there's a remainder. So this is not true. We come back up here. We increase I, which is not smaller than half the number. So we're done. We come to the bottom. What is the value of is prime? It's still true. So we say, oh yeah, 5 is a prime number. So how did that work? So what we did is we just checked all the numbers up until half to see if they divided in evenly. Maybe we should do this with a bigger number. What if it was 15? 15 divided by 2, that doesn't work. So if it doesn't work, we'd go on to the next number. So we go to 3. 15 divided by 3, ooh, I think that goes in evenly. So is prime would now change to false. Okay. It would keep going. It would check 4 and 5 and 6 and 7. It doesn't matter that it keeps going because is prime is now false. And when you exit the loop, not true, so false, so it says it's not a prime number. So again, 5 is a prime number because the only divisors are 1 and 5. 15 is not prime because you can find a number other than 1 that goes into it. So all this does is check all the numbers up until half. Can you understand why you go to half? Once we've gone beyond half of this number, there's no way you can get into it. Think about it. Is it possible to divide 24 by 15 evenly? Not a chance. So the biggest number you could possibly get is half of it. After that, it's a waste of time. All right, so assignment 6 has a lot of interesting questions in using modular division. They're some of the toughest ones in the course. So work hard.